Okay, this is an enzyme question. The enzyme involved is known as lactic hydrogenase, right? So what does lactic hydrogenase does? It catalyzes the conversion of lactic acids as shown in the following equation. So we know that this is called this is lactic dehydrogenase, and what happened is in the presence of NAD, it will give you a product that look like this. Okay, now the questions continue. We have two forms of isomers. You have this and this, version A and version B. Okay, so as indicated here and here, as shown below. Now look carefully. Actually, the chemical structure looks similar, right? Just that the OH appears here and the OH appears here, but the chemical formula is still the same. Okay, so let's continue with the question. NADH absorbs ultraviolet light. So which one absorbs ultraviolet light? NADH, which is this molecule over here, right? Absorbs UV. So what does it mean? It means that if the reaction occurs in this direction, NADH will be produced. So when NADH is produced, that means this is being produced as well, and the reaction has been catalyzed by the enzyme lactic dehydrogenase. Correct not? Alright? So the activity of lactic dehydrogenase was compared in these two graphs. The absorbance of ultraviolet light was measured using an ultraviolet spectrophotometer, and the graph shows the results. Now on the graph on the right is for the plus isomer, which is this one. On the left is a negative isomer, which is this one. Now what do you see? This is absorbance, right? That means light is being absorbed. On the left, it shows that as time goes, the absorbance increase. On the right, as time goes, the absorbance remains the same. So there's no change here. Whereas there is increase in the absorbance. So what does it mean? It means that the enzyme is able to catalyze this isomer, okay, to produce products that is capable of absorbing UV, right? Whereas the reaction does not change here on the right. It doesn't work, okay, but it works here. So what will be the best answer? Molecules of both isomers feed the active site? No, not true. If it feeds the active site, the reaction will take place for both, and there should be absorbance increase in both isomers. Molecules of neither isomer feed the active site? Not true, because on the left graph there is absorbance. Enzyme is specific to the negative isomer. Yes, correct. Therefore, there's a reaction going on. Enzyme is specific to the plus isomer. Not true. There is no reaction on the right graph. So C is the correct answer.